Have you ever imagined waking up, looking through your window, and seeing the rusty red landscape of Mars instead of Earth's blue sky? What once sounded like pure science fiction is now becoming one of humanity's most ambitious goals. Scientists, engineers, and space agencies around the world are seriously asking one extraordinary question: can we actually build a city on Mars? For decades, Mars has captured our imagination because it is the most Earth-like planet in our solar system. Although its environment is incredibly harsh, it offers conditions that make it the strongest candidate for future human settlement. Unlike the Moon, Mars has seasons, polar ice caps, a 24-hour day that is surprisingly similar to Earth's, and evidence that liquid water once flowed across its surface. These similarities have convinced many experts that Mars could someday become humanity's second home. But building an entire city millions of kilometers away is one of the greatest engineering challenges ever imagined. The first obstacle is distance. Mars is located anywhere between about 55 million and over 400 million kilometers from Earth, depending on where both planets are in their orbits. Even using today's fastest spacecraft, reaching Mars could take between 6 and 9 months. That means every tool, machine, food supply, medical resource, and building material must survive an incredibly long journey through space. Unlike Earth, Mars has almost no breathable oxygen. Its atmosphere is made up mostly of carbon dioxide and is less than 1% as dense as Earth's atmosphere. Without specially designed habitats and life support systems, humans would survive only a few moments on the Martian surface. Temperature is another enormous challenge. During the day, temperatures near the equator may briefly rise above freezing, but nights can plunge below -100 degrees Celsius. Any future city would need powerful insulation and heating systems capable of protecting residents from these extreme conditions. Radiation presents an even greater danger. Mars has no strong global magnetic field and only a very thin atmosphere, leaving the surface exposed to harmful cosmic radiation from space. Over months or years, this radiation could significantly increase the risk of cancer and other serious health problems. To solve this problem, scientists believe future homes may need to be built underground or covered with thick layers of Martian soil. Some researchers are even exploring the possibility of constructing habitats inside ancient lava tubes, discovered beneath the Martian surface. These enormous underground tunnels could naturally shield people from radiation, meteorites, and temperature extremes. Finding water is another critical requirement for any successful Martian city. Fortunately, multiple missions have confirmed that large amounts of frozen water exist beneath the surface and inside the polar ice caps. Future settlers could melt this ice to produce drinking water, grow crops, generate oxygen, and even manufacture rocket fuel. This process would dramatically reduce the amount of supplies that must be transported from Earth. Food production will also play a vital role in the survival of any Martian colony. Constant resupply missions from Earth would be too expensive and unreliable. Instead, astronauts would likely grow vegetables inside carefully controlled greenhouses using artificial lighting and hydroponic farming systems. Scientists have already conducted experiments growing crops in soil designed to imitate Martian conditions. Although challenges remain, these experiments show promising results for future space agriculture. Energy is another essential part of building a city on Mars. Solar panels could provide electricity during the day because Mars still receives significant sunlight despite being farther from the sun. However, frequent dust storms can reduce sunlight for days or even weeks. For that reason, many experts believe nuclear reactors will become the primary source of reliable power for future Martian settlements. Modern compact nuclear systems could generate continuous electricity regardless of weather conditions. Construction itself would require completely new engineering techniques. Sending traditional building materials from Earth would be extremely expensive. Instead, scientists hope to use Martian resources to construct homes, roads, laboratories, and storage facilities. Advanced robotic systems and massive 3D printers could transform Martian soil into durable building blocks before humans even arrive. This approach, known as In-Situ Resource Utilization, is considered one of the most important technologies for future space colonization. Autonomous robots would likely prepare landing sites, construct habitats, install solar farms, and inspect equipment years before the first astronauts arrive. Artificial intelligence could coordinate many of these construction projects while communicating with engineers back on Earth. Because radio signals between Earth and Mars can take up to 22 minutes each way, robots and settlers would need to make many decisions independently. Communication delays mean emergency situations cannot always rely on immediate assistance from Earth. Future Martian cities must therefore become highly self-sufficient, capable of solving problems without waiting for instructions from mission control. Healthcare presents another major challenge because hospitals on Earth would be millions of kilometers away. Doctors living on Mars would need advanced medical equipment, robotic surgical systems, and the ability to manufacture medicines locally. Scientists are also studying how low gravity affects the human body over many years. Mars has only about 38% of Earth's gravity, which could weaken muscles, reduce bone density, and affect human health in ways we still do not fully understand. Understanding these biological changes will be essential before large populations can safely live on the Red Planet. Despite these enormous challenges, engineers and scientists continue developing technologies that bring the dream of a Martian city closer to reality every year. The dream of building a city on Mars is no longer limited to science fiction because many space organizations are actively developing the technology needed to make it possible. Robotic missions already explore the Martian surface, collecting valuable information about its climate, soil, atmosphere, and potential resources. Every new mission helps scientists understand how future astronauts could survive and eventually establish permanent settlements. One of the biggest priorities is learning how to produce essential supplies directly on Mars instead of transporting everything from Earth. Scientists are developing systems that can extract oxygen from the carbon dioxide-rich Martian atmosphere. This technology could provide breathable air while also producing oxygen needed for rocket engines during return missions. Researchers are also studying methods for creating fuel by combining locally available carbon dioxide with hydrogen carried from Earth or extracted from water. If successful, future spacecraft may launch from Mars using fuel manufactured entirely on the planet itself. Water recycling will become another essential part of daily life in any Martian city. Every drop of water used for drinking, cooking, cleaning, and farming would be carefully collected, purified, and reused. Advanced recycling systems aboard the International Space Station already recover most of the water astronauts use, providing valuable experience for future Mars missions. Future Martian homes will likely operate as completely closed ecosystems where almost nothing goes to waste. Waste materials could be recycled into fertilizer, construction materials, or even new manufacturing resources. Engineers are also designing advanced spacesuits that allow astronauts to work safely outside for extended periods. These suits must protect against radiation, freezing temperatures, sharp dust particles, and the planet's extremely low atmospheric pressure. Martian dust itself creates another unexpected challenge. The fine particles are highly abrasive and can damage machinery, block solar panels, and cling to equipment much like static electricity. Future engineers must develop special coatings and cleaning systems to keep habitats and vehicles functioning properly. Transportation inside. A Martian city will also look very different from life on Earth. Pressurized electric vehicles may connect neighborhoods, research stations, farms, and industrial zones while protecting passengers from the hostile environment. Underground tunnels could provide safe passage between important buildings without requiring astronauts to wear spacesuits every time they travel. Some scientists even imagine magnetic transportation systems connecting distant settlements across the Martian surface. Education will play an important role if families eventually begin living on Mars. Children born on Mars may grow up knowing Earth only through photographs, videos, and stories shared by earlier generations. Schools would combine traditional education with advanced science, engineering, agriculture, and survival training tailored specifically for life on another planet. Entertainment and mental health will become just as important as food and shelter. Living inside enclosed habitats millions of kilometers from Earth could create feelings of loneliness, isolation, and homesickness. Future cities may include parks filled with plants, artificial lakes, sports facilities, virtual reality entertainment, and community gathering spaces to improve quality of life. Scientists believe exposure to nature plays a major role in maintaining emotional well-being, even if that nature must be created inside protected domes. Some architects have even proposed transparent observation areas where residents could safely watch Martian sunsets and the stars above. Mars offers spectacular night skies because its thin atmosphere creates very little light pollution. Looking upward, settlers would see Earth as nothing more than a tiny, bright star shining across millions of kilometers of space. Economics also raises fascinating questions about the future of a Martian civilization. Initially, building a city would cost hundreds of billions of dollars. Governments, private companies, and international partnerships would likely share the enormous financial burden. Over time, local industries such as scientific research, advanced manufacturing, rare mineral exploration, and technology development could help support the growing settlement. Some experts believe Mars could eventually become a center for producing products impossible to manufacture under Earth's gravity. Others imagine tourism becoming an entirely new industry where adventurous travelers spend months visiting humanity's first extraterrestrial city. Legal questions must also be answered before permanent settlements become reality. Who would govern a Martian city? Would settlers follow the laws of their home countries, or would Mars develop its own independent legal system? International agreements currently state that no nation can claim ownership of Mars, but future permanent settlements may require entirely new forms of international cooperation. Ethical questions are equally important. If microbial life still exists beneath the Martian surface, should humans disturb that environment? Protecting any possible native life while exploring the planet responsibly remains one of the biggest priorities for scientists today. The first Martian city will almost certainly begin as a small research base housing only a few dozen people. As technology improves, additional habitats, farms, laboratories, and manufacturing centers could gradually expand into a thriving settlement. Decades later, thousands of people might call Mars their permanent home. One day, children could be born there, businesses could operate there, and entire communities could flourish beneath protective domes. The journey will not be easy, and many technical challenges still remain unsolved. Yet throughout history, humanity has repeatedly achieved goals once considered impossible. Crossing oceans, flying through the sky, landing on the moon, and building permanent space stations all began as distant dreams. Perhaps building a city on Mars will become the next giant leap in humanity's extraordinary story. Whether it happens within a few decades or much later, the possibility reminds us that the future is limited only by our imagination, determination, and willingness to explore the unknown. The first city on Mars may seem impossible today, but history has shown that today's impossible ideas often become tomorrow's greatest achievements.